Hello, my name is John Chapman, and today I'm going to be talking about the open source software computer risk framework that myself and Hari Venugopalan, both from UC Davis, worked on and created here. So, getting into it. What this is a framework to define the risk that individual developers represent to a software project, specifically open source software projects. And the motivation behind this is open source software brings with it some additional attack vectors when compared to closed source software. Just intuitively, bad actors have the ability to target code bases by including vulnerabilities. It could be a 0-day or just even insecure defaults. And the problem though is that following this sort of course of analysis would require some sort of method to be able to ascertain the motivations of the individual developers. But we don't have the ability to do that with the current data sets that we have. So we had to move on. So given the fact that we couldn't ascertain the motivations and figure out the bad actors necessarily, sort of taking a step back from that, what if there were a way that we could quantify the risk that any particular pull request represented to a given project? And so then that was sort of the idea behind what it is that we're doing. So now, there's this concept in software engineering called Linus's Law, and the idea is that given enough eyeballs, all bugs are shallow. And essentially what that means is if you have enough people reviewing a code base, all bugs or vulnerabilities are eventually going to reveal themselves. And so, sort of the follow-on question for me is how many eyeballs are actually needed for full coverage? And even if we had enough eyeballs, what could those eyeballs be doing instead? So let's try and maximize their utility in other ways. And so thinking about that, we came up with a couple of research questions. So can an accurate predictive model be created to give insights into future risk of a given contributor, as well as can a derived composite risk index be used to accurately predict which open source projects will be assigned a CVE in the near future? Or to put it another way, which projects are more likely to have the inclusion of a vulnerability at a future point in time? And now let's discuss some of the past efforts in this field. So as noted in our paper, a lot of the work is centered around static code analysis. And we can see from the NIST website here all the ones that they record, which they are numerous and they are specific for certain languages. Some of them work on an array of languages, but most of them are fairly specific. And so we know that static code analysis is not going to be a perfect solution for this. And so some of the other efforts in this area have been, increasing the amount of education that developers have, specifically in the areas of security. And then there have been some other proactive scanning tools to look for vulnerabilities, as well as, just having more thorough code reviewers. So training the people that are doing the code reviews to look for specific things to increase the security of the project. So with that in mind, our approach, we wanted to be a bit more proactive rather than reactive and provide some bit of predictive capability. So what we did is we mapped the individual users to projects on GitHub, and this created essentially a bipartite relationship between users and projects. Then we created a mapping from the National Vulnerability Database and took CVE data, and we mapped that to projects on GitHub. The CVE scores were then aggregated and then that was mapped to the individual users as a sort of a temporal flow-through arrangement. So to support this work, we needed to come up with some definitions moving forward. So we wanted to be able to define the relative contribution of a contributor, or a user, denoted here as U sub I, to project, given project, denoted here as P sub I, at a given time. And so we also needed to look at what the partial risk score of a contributor was that was derived from their work on a particular project at a given point in time. And that's the second definition here. And so we can see these now a bit more formally. And these are going to feed into our overall risk scores, which we can see here. So we can see here the risk score of a contributor or a user at a given point in time is basically it's an aggregate of all the risk scores from the projects that a particular user has contributed to up until that point in time. And that's going to be divided by the number of commits that the user has contributed at that point in time, going back to the beginning of the data set. So basically what that does is it kind of accounts for a user who has made many significant sort of contributions to a project without having introduced vulnerabilities. It sort of helps to lower their overall risk score. And so by way of results, we looked at approximately the top 1,000 users. And so those were the folks with the most contributions on GitHub. And so then we attained a list of all the projects they'd contributed to, and we queried those against the associated CVEs. And so we saw a fairly strong correlation between the average number of commits per user and the number of filed CVEs. Okay, but then more importantly, what we saw is that as the computed developer risk score, the metric that we came up with here, as that increased, the project vulnerability score increased as well. And so we saw that correlation between having riskier developers means that you have essentially a riskier project. And so then when you get a pull request from a developer like that, I think it behooves the project maintainer to take a little more time and look at what that developer is attempting to contribute to the project. So sort of next steps for this work. Something I'd like to do is work on cleaning our data sets a little bit. I think there's a degree of difficulty in correlating projects on GitHub to the data found on the National Vulnerability Database, and ensuring that that all the vulnerabilities are accounted for when computing those aggregate scores for projects. And then something else I'd like to do as sort of a next step to this work is use this as an input to just sort of a basic machine learning model, utilizing all the associated metadata on GitHub and being able to pull the NVD data out entirely and use just the data found there on GitHub. I think that might prove interesting. So anyhow, I hope you enjoyed it. I enjoyed working on it. And if you have any questions, please feel free to reach out. I believe my email was at the beginning of the presentation. And you can reach out to myself or my co-author, Hadi. We'd both love to answer any questions that anyone has. Thanks again. Appreciate you sitting through this, and Slava Ukraina.